Okay, let's unpack this. What if life isn't just, well, life as we know it?
You mean like carbon and water and all that?
Exactly. What if it exists in forms so alien, so fundamental, they'd shatter our understanding of biology, physics, maybe even reality itself? What if the strangest stuff in the universe, the weird lights in the sky, the fundamental weirdness of reality itself, is alive?
Whoa. Okay, that's a big opener.
Welcome to the Deep Dive.
Glad to be here.
This is where we take your stack of sources, the articles, the research papers, the notes you've gathered, and dive headfirst into the absolute coolest, most mind-bending ideas within them.
Yeah, it's always fascinating to see what connections emerge.
Today, we're tackling some truly out-there concepts, connecting the dots between the tiniest particles, the complexity of the human brain, and, well, unexplained phenomena.
And just to be super clear, everything we talk about today comes only from the material you've given us. We're sticking strictly to the sources.
That's right. Our mission in this deep dive is to explore a fascinating hypothesis presented in this material: the possibility of plasma life.
Plasma life sounds like something straight out of sci-fi.
It does. But we're going to break down the scientific building blocks, no matter how initially complex they might seem.
Right. Understand the underlying theories that weave them together and follow where these sometimes astonishing ideas might lead us.
It's a journey that starts at the absolute smallest scales.
Like really small.
And expands outwards to the cosmos. Absolutely. We're not bringing in outside information. We're simply being your guides through this incredible roadmap of discovery contained within your sources.
So stick with us, because this is going to challenge some fundamental assumptions you might hold about the universe and everything in it.
Get ready for some serious aha moments. And while you're listening, please take a moment to like and subscribe, and definitely hit that notification bell so you don't miss the next deep dive into the unknown.
Last but not least, we have members-only videos now on the most in-depth deep dives. Okay, so plasma life. To even begin thinking about that, we need to recalibrate our sense of scale. We have to start with the very fabric of existence.
Right. Scaling down, way, way down. You, the listener, imagine yourself standing there. You're maybe, 1.8 meters tall?
Average human height.
What are you actually made of? Atoms, obviously. But the sheer number, the sources say a human body contains on the order of 7,000 trillion atoms.
7,000 trillion. That number just breaks my brain. It's almost meaningless. It's so big.
I know. And most of that, about 99%, is just three elements: hydrogen, oxygen, and carbon. The basic stuff of life.
But even those atoms are fundamental building blocks. They're not what we think. They aren't solid little balls.
Not at all. When you zoom inside the atom, things get really weird and really empty.
Extremely empty. So inside each atom, you've got even smaller particles, electrons orbiting a central nucleus, right?
Yep, nucleus made of protons and neutrons, the classic model.
But the scale within the atom, the material, gives this amazing analogy. Imagine the nucleus is like a tiny marble.
Okay, got it. Marble nucleus.
Protons and neutrons packed inside, and the electrons orbiting it. They're over 1,000 times smaller than a proton or neutron. Think. Grains of sand.
Marble nucleus, sand grain electrons. Still sounds packed.
But here's the kicker. If that nucleus is a marble, where's the electron sand grain? It's orbiting about 1 kilometer away.
1 kilometer? Are you serious?
That's the analogy from the sources. 1 kilometer.
So between the marble and the grain of sand, there's just nothing.
Mostly nothing. This immense, boundless, empty space within the atom itself. What feels solid to us is fundamentally, incredibly, mostly empty space.
Mind blown already. We can go smaller, right?
Oh, yeah. Atoms join up to form molecules. They're bigger, maybe 1/1000th of a meter across, about 10 times an atom size.
But inside the atom, the nucleus itself is tiny compared to the whole atom.
Way smaller, about 10,000 times smaller. And then inside the protons and neutrons, you find quarks.
Quarks, okay, how small are they?
Roughly 1,000 times smaller than the nucleus they're inside. The sources give the size as about 1/1000th of a meter. That's 10 to the minus 18 meters.
1/1000th of a billionth.
Yeah.
It's just impossible to picture.
Pretty much. And the sources, they don't even stop there. They mention string theory, taking us down to the theoretical smallest dimension, the thickness of a superstring.
Which is?
10 to the minus 33 meters. 1033 meters. We're talking scales so far beyond our experience, it's almost philosophical.
And it's down at these tiny scales that reality stops playing by the rules we know.
Exactly. Classical physics just doesn't cut it anymore. You enter the realm of quantum mechanics, pure weirdness.
And the classic example of that weirdness is the double-slit experiment. The sources bring this up.
Ah, yes, the experiment that launched 1,000 headaches. You fire particles like photons, particles of light at a barrier with 2 narrow slits in it.
Right. Classically, you'd expect just 2 lines on the detector screen behind the slits where the particles went through. Simple.
But that's not what happens. Instead, you get this pattern of multiple bright and dark bands, an interference pattern, like waves overlapping.
Which is weird enough if light is a wave, but photons are particles.
And here's the truly astonishing part highlighted in the sources. Even if you fire the photons one at a time, each single photon seems to interfere with itself. It behaves as if it goes through both slits simultaneously.
How? How does one particle go through 2 places at once?
It somehow knows where to land on the detector to build up that wave pattern over time, even when sent alone. It's like it's aware of the whole setup.
It's like the particle is ghosting itself just to mess with our heads. What's the proposed explanation in the sources for this? Impossible behavior.
Well, this is where the concept of the quantum potential comes in, especially as developed by physicist David Bohm.
Quantum potential, okay.
In the double-slit experiment, Bohm's idea suggests the particle isn't just moving randomly, it's being guided. And this guidance is non-local.
Non-local, meaning what exactly? Instantaneous influence regardless of distance.
That's the crux of it. The quantum potential isn't a force like electromagnetism, pushing or pulling. It's more like an information field.
An information field.
Yeah. The sources describe it like a kind of radar for the particle, telling it where the constructive and destructive interference paths are based on the whole experimental setup. And this guidance works instantly, independent of space and time.
Okay, my brain is officially bent. An information field guiding single particles non-locally.
It gets weirder. This non-locality is even more apparent in quantum entanglement.
Ah, entanglement. The spooky action at a distance.
Exactly. The sources describe the classic setup. You create 2 particles together, say photons, in a linked state. Then you send them flying off in opposite directions, maybe miles apart.
Okay. 2 linked particles far apart.
Now, if you measure something about one particle, like, say, you use a filter to change its polarization or direction.
Yeah, what happens in the other one?
The instant you measure the first one, the second one, no matter how far away, instantly changes its state to be correlated with the first one.
Instantly. No delay. No signal traveling between them.
Apparently not. The sources use this great analogy. Imagine you and I each have a pocket miles apart. In my pocket is a red ball, in yours is a blue one. They're entangled.
Okay.
If I reach in and somehow instantly change my ball to blue, the moment I do that, your ball instantly changes to red.
Without us talking. Without any connection.
Right. It's not that the balls are physically linked. It's the information about their state, one red, one blue, that's shared non-locally, instantly across the distance.
That's the spooky part that bothered Einstein so much. It seems to violate the idea that nothing can travel faster than light.
It does seem to, and the sources explain that Bohm's quantum potential is actually a way to explain this, because unlike classical forces, the strength of the quantum potential doesn't depend on distance.
It doesn't get weaker the further apart the particles are?
Nope. Its effect only depends on the shape or the overall configuration of the system. It is an information field. This non-local information field underpins the correlations we see in entanglement experiments, resolving the EPR paradox.
So the universe, at this fundamental level, is connected by this invisible information network that operates outside our usual concepts of space and time.
That's the picture painted by these ideas in the sources, a deeply interconnected reality. Though they do mention a big practical hurdle: decoherence.
Decoherence, what's that?
It's basically the loss of quantum information. When a quantum system interacts with its environment, bumps into air molecules, gets hit by photons, its delicate quantum state, its entanglement, gets disrupted and lost.
So that's why we can't just build entanglement communicators that work across the galaxy.
Pretty much. Decoherence currently limits our ability to maintain and use entanglement for things like quantum teleportation to, say, tens of kilometers. But the underlying principle, non-locality, that's still a fundamental insight.
And this idea of interconnectedness, particles not being truly separate. This really influenced Bohm's whole view of the universe, didn't it?
Absolutely. He argued that particles aren't fundamentally individual things. They're more like ripples or patterns emerging from a deeper, undivided whole. A universal organism or process he called the holomovement.
So the separation we see, me here, you there, that's sort of an illusion.
At the deepest level, according to Bohm's view in the sources, yes. It's an illusion projected from this underlying interconnected reality. It shifts the view from a mechanical universe of separate parts to a flowing, unified whole.
And he felt classical physics was like being stuck inside a map we drew, instead of exploring the actual territory.
That's a great way to put it, and it's reflected in the source material. Our science often focuses on describing what we think reality is based on our limited observations, rather than embracing the full, stranger reality hinted at by quantum mechanics, an epistemological trap versus an ontological reality.
Okay, so non-locality, entanglement. The quantum potential is an information field. The universe is maybe one big interconnected organism. These are the weird quantum building blocks.
Foundational concepts. They show reality is far stranger than it looks, and they're absolutely essential for understanding the really wild possibilities the sources explore next.
Right. Let's scale back up now, from the quantum weirdness to something incredibly complex but maybe more familiar. The human brain.
The 3-pound universe between our ears.
The sources mention the common view. The brain is basically a fancy biological computer, a PC in the head.
Yeah, that analogy is everywhere. But does it really capture everything, especially subjective experience, consciousness?
And the sheer complexity is staggering. The numbers in the sources, 100 billion neurons. Each neuron connected to maybe 1,000, maybe even 10,000 other neurons through synapses.
Well, like switches, trillions upon trillions of connections. The sources estimate the brain performs something like 10 to the 15th power processes every second.
10 to the 15, that's a quadrillion.
Yeah.
1,000 trillion operations per second.
1,000 trillion.
Yeah.
Just, wow, that's immense classical computing power.
But is that all there is to consciousness? Just complex calculations? Or could something quantum be happening in there too?
Well, this brings us to the quantum brain hypotheses discussed in the sources, particularly the ideas put forward by anesthesiologist Stuart Hameroff and physicist Roger Penrose.
Right, the Orcher-Orr model.
Yeah.
This is where it gets really interesting and controversial.
It is controversial. The core idea is that quantum effects might be crucial for consciousness, going beyond just neuron firing.
But wait, we just talked about decoherence. How could fragile quantum states possibly survive inside a warm, wet, noisy brain? Seems impossible.
That is the major challenge, absolutely. But Hameroff and Penrose focus on specific structures inside neurons called microtubules.
Microtubules, what are they?
They're tiny, hollow cylinders made of protein, part of the cell skeleton. They help maintain shape, transport stuff around. The hypothesis suggests these microtubules might act like, well, like protected environments where quantum effects can occur.
Protected from the noise of the cell.
Potentially. The idea is they could support quantum coherence, where quantum states are maintained across large parts of the brain. Almost like a biological version of a Bose-Einstein condensate, where particles act as one quantum wave.
Okay, so microtubules are potentially the quantum hardware. How does it work?
The proposed mechanism involves entanglement, specifically entanglement between the protein subunits that make up the microtubules, called tubulins.
Tubulins, got it.
The hypothesis suggests that potentially billions of these tubulins within and across many neurons could become quantumly entangled. Think of it like the entangled photons, but scaled up massively within a biological system.
A brain-wide entangled state.
That's the idea. And according to this hypothesis in the sources, consciousness itself emerges from the quantum collapse of this huge entangled state.
The collapse of the wave function, but on a massive scale in the brain.
Yes. They describe it as a rapid two-stage process.
2 stages. Okay, break that down.
Stage 1 is called the unconscious moment. The tubulins are in a quantum superposition, existing in multiple states at once. The brain is kind of processing possibilities in this quantum limbo. It's very brief.
And stage 2?
Stage 2 is the conscious moment. This is when that complex, entangled superposition collapses into a single definite state. This collapse event is the moment of conscious experience, according to the hypothesis. They call this specific process orchestrated objective reduction, or OR.
Orchestrated objective reduction. Quite a mouthful. What does the orchestrated part mean?
Orchestrated suggests the collapse isn't random. It's guided or influenced, perhaps, by the inputs the neuron receives from other neurons via synapses. It's tuned by the brain's activity.
And objective reduction.
That's Penrose's contribution. He proposed that the collapse isn't caused by observation, but by an objective physical threshold, possibly related to gravity effects at the quantum level. So it's a physical process happening in the brain.
Wow. So consciousness isn't just computation. It's the actual physical process of quantum state collapse happening continuously within the microtubules of our neurons.
That's the core of the ORCH or R hypothesis as presented in the source material. It links the subjective feeling of being aware to a specific large-scale quantum physical event. It elevates the brain from just a wet computer to maybe a macroscopic quantum device.
It's mind-blowing.
Yeah.
And highly debated, I
Oh, absolutely. But it's a fascinating attempt described in the sources to bridge quantum physics and neuroscience to explain the mystery of consciousness.
And then the sources take this entanglement idea and just launch it into the stratosphere with the cosmic brain hypothesis.
Yeah, this is where things get really speculative, but it flows directly from the entanglement concept. The hypothesis asks, what if entanglement isn't just local to one brain or temporary? What if quantum entanglement is maintained across vast cosmic distances? What if all the functional units of consciousness, the neural cells, or their equivalents in all biological creatures everywhere in the universe are fundamentally entangled?
Wait, what? Like, every thinking being in the cosmos is quantumly linked. A universal mind meld.
That's the staggering implication presented. A universe-wide entanglement network connecting all consciousness.
Okay, that sounds completely like science fiction. But if that were true...
If it were true, the sources speculate advanced alien civilizations wouldn't need radio telescopes to talk to us. They could potentially send non-local messages directly into our brains, instantly, across any distance.
Directly into our thoughts. Bypassing space and time. How would that even work?
It relies on the entanglement. Changing the state of their neural cells would instantaneously change the state of our entangled counterparts.
Is there any way, even theoretically, we could possibly detect something like that? It seems untestable.
Well, the sources do mention some proposed methods, drawing on work by quantum biophysicist Fred Thailde. One idea is to use standard EEG to monitor brain waves.
Okay, measuring electrical activity in the brain.
Right, and then apply complex mathematical algorithms. The sources mention things like FFT or KLT, fast Fourier transform, or Carhoonen-Love transform. Think of them as tools to sift through the noise of normal brain activity.
Sifting for what?
For patterns. Structured signals hidden within the chaos that don't look like they originate from inside the brain, but might suggest an external, non-local, intelligent source, like receiving a message through this cosmic entanglement network.
So, analyzing our own brain fez for alien emails, that's
ambitious. Highly ambitious. And the sources even speculate about sending messages back. Again, highly speculative, but based on the entanglement hypothesis. Maybe using targeted laser pulses aimed at our own neural cells.
Zapping our brains with lasers to talk to aliens.
Not quite like that. The idea isn't that the laser carries the message across space. It's that the laser pulse could precisely change the quantum state of the entangled tubulins in our microtubules.
Ah, and because they're entangled with others across the universe.
That change would be reflected instantaneously in the corresponding cells elsewhere. Non-local information transfer triggered locally. It's pure hypothesis, but it shows where these quantum ideas can lead when applied biologically and cosmically based on the source material.
Okay, we've gone from empty atoms to quantum weirdness to quantum brains to a possible cosmic consciousness network. Now let's bring it all together for the main event, the plasma life hypothesis.
Right. This is the central idea we're diving into, drawing heavily on the work mentioned in your sources, like that of astrophysicist Massimo Teodorani.
It takes all those quantum concepts, entanglement, non-locality, coherence,
and applies them not to biology, but to plasma.
Plasma, fourth state of matter, not solid, liquid, or gas.
Exactly. It's an ionized gas atoms stripped of some electron, leaving a mix of free electrons and positively charged ions. Super hot, electrically charged gas, basically.
And it's everywhere, right? Stars are plasma, lightning, the aurora, most of the visible matter in the universe.
The most common state of matter, by far. Now, here's the hypothesis. Under certain special conditions.
Special conditions.
Conditions where decoherence, that quantum-killing noise, is somehow avoided or minimized. Under those conditions, the hypothesis suggests the particles within the plasma, the ions and electrons, could become quantumly entangled.
Entangled, like the tubulins in the brain hypothesis or the photons.
Just like that. The sources reference Bohm and Teodorani here. The idea is these plasma particles become linked non-locally, perhaps across large volumes of the plasma cloud.
So they're not just bouncing off each other classically anymore.
Not just via electromagnetic forces, they be connected by this deeper quantum entanglement. And if enough particles become entangled and stay that way, the hypothesis proposes this entangled plasma could form a quantum coherent complex. It would behave collectively, like a single quantum entity. Similar, the sources say, to a Bose-Einstein condensate or
the proposed coherent state in the microtubule.
Exactly. The sources explicitly draw that parallel. They state this idea of entangled plasma forming a coherent quantum complex is reminiscent of the Penrose-Hameroff quantum consciousness model in the brain.
Okay, wait. If the plasma particles are behaving quantumly, in a way analogous to the structures thought to be involved in consciousness in the brain,
then the hypothesis takes the leap.
Yeah.
You could potentially have a structure that functions like a plasma-like brain.
a brain made. Oh, plasma.
That's the jaw-dropping conclusion presented in the sources?
Not carbon, not water, not neurons,
That's
just
right.
charged gas acting like a brain.
Potentially. And if that's possible, then this plasma formation wouldn't just be some weird physics phenomenon. It could be
Intelligent.
sentient.
An intelligent and sentient being, according to the hypothesis.
Wow. Plasma life. How would such a being even interact or communicate? The sources suggest one possibility is through modulated light signals, changing its brightness, color, or pulsing in complex patterns.
Modulated light. Like sending Morse code with plasma flashes.
Potentially much more complex than that. And interestingly, the material connects this to real-world observations. It mentions that unusual structured light variability has been reported in places like Hessdalen, Norway, a hotspot for anomalous lights, citing Teodoran's own research there.
So some unexplained light phenomena might, under this hypothesis, be attempts at communication by plasma beings.
It's offered as a possible explanation that fits the framework. And think about the implications for where life could exist.
Right. Carbon life needs very specific conditions. The Goldilocks zone. Not too hot, not too cold, liquid water.
Exactly. But plasma. Plasma exists in extreme environments. Stars, nebulae, planetary cores, lightning.
So plasma life wouldn't be limited to cozy planets like Earth.
Not at all. According to the sources, these beings could potentially exist everywhere in the universe where plasma can form. Interstellar space, gas giants, maybe even within our own atmosphere.
Our atmosphere. How?
The sources mention potential geophysical triggers for plasma, like piezoelectricity in rocks. Certain rocks, under stress, say, from tectonic activity, can generate electrical charges.
And that charge could ionize the air, creating plasma.
Potentially, yes, creating localized plasma phenomena. The sources suggest this could even be a mechanism for generating these hypothesized plasma life forms, linking geology, physics, and potentially biology in a completely novel way.
So earthquakes could literally be giving birth to plasma beings.
Yeah.
That's wild.
It's a radical idea. And the sources stress that if this hypothesis is correct and it needs proof, it would fundamentally change science.
How so?
It would mean disciplines we keep separate, physics, geophysics, biology, even neurophysiology would suddenly merge in certain contexts. You'd need a unified science to understand these phenomena.
A total paradigm shift.
Immense. But again, it's a hypothesis. The sources emphasize it needs rigorous testing. They mention specific tests were planned back in 2007 by Teodoran and Nobili to try and find evidence for or against it.
So scientists are, or were, thinking about how to actually test this seemingly untestable idea.
Yes. Because the implications are profound. It's not just about finding aliens. It's about fundamentally redefining what life and consciousness can even be. It pushes the boundaries of multiple fields at once, all stemming from those core quantum ideas.
Okay, this naturally leads us to think about, well, things people report seeing that don't fit. Unidentified aerial phenomena, UAP.
Right. The sources dedicate a good chunk of discussion to the scientific study of UAP, looking at different explanations. And the plasma life hypothesis is presented as one specific, if speculative, possibility to consider among others.
Does the description of UAP behavior match what you might expect from, say, a conscious plasma entity or something operating under advanced physics?
There are definitely overlaps mentioned in the sources. Many UAP reports describe things with simple geometric shapes, spheres, disks, triangles, consistent shapes, often with no visible propulsion.
And they're often silent, right? Or make weird humming sounds.
Exactly. Silent movement is common. And a really key characteristic highlighted is their association with magnetic fields.
Ah, the compass is going haywire, electronics failing.
Yes. Witness accounts often mention that. And the sources point to actual measurements, like those in Hessdalen, Norway again. During sightings of anomalous lights, instruments detected magnetic field fluctuations, zero point 0.5 up to 10 nanotesla spikes, correlated with the phenomena.
Nanotesla. Is that a lot?
It's small, but detectable above background noise. The sources estimate that a UAP source might realistically produce fields in the range of 10 to maybe 100,000 nanotesla at measurable distances, so the Hessdalen results are suggestive, if not conclusive proof of a strong field.
What about how they look and move? That's often the strangest part.
High luminosity, definitely. Often intensely bright, sometimes changing color rapidly. And then there's the maneuverability.
The instant acceleration, right angles, stopping on a dime.
Yeah. The sources mention reports of accelerations to thousands, even tens of thousands of kilometers per hour almost instantly. Moves that seem to defy inertia and our understanding of physics. Plus, reports of appearing or vanishing instantly or cloaking, sometimes even correlated with power outages.
That kind of performance. It's easy to see why mainstream science was hesitant for so long. It sounds impossible.
And the sources acknowledge that history. They mention the Condon Report, Project Blue Book, and how phenomena that seem impossible according to current physics often get dismissed. It fits Kuhn's idea about anomalies being hard to see within an existing scientific paradigm.
But just dismissing decades of consistent reports isn't very scientific either.
Exactly. The sources make that point strongly. Extraordinary claims need extraordinary evidence, yes, but you have to look for the evidence. You can't just ignore persistent phenomena that don't fit.
So what's changed? The sources talk about a shift, with NASA, the AIAA, and projects like Harvard's Galileo project getting involved.
Right. There's a growing push for systematic instrumented study. The Galileo project is a prime example described in the material. Their goal is basically to conduct a thorough census of the skies using a whole battery of instruments.
A census? What kind of gear are they using?
It's a multimodal approach. High-res optical cameras, wide and narrow field, thermal infrared cameras FLIR to see heat signatures, passive radar to track objects and measure distance, radio spectrum analyzers to listen for emissions, microphones for sound, including infrasound and ultrasound.
Wow, covering all the bases.
And environmental sensors, too. Specifically magnetometers, they mention their custom NPAC-Man instrument to measure magnetic fields precisely, plus particle detectors.
So they're trying to capture every possible type of data simultaneously if something unusual shows up.
That's the idea. Get objective, quantitative data, measure the key parameters, image, distance, size, luminosity, velocity, acceleration, magnetic field signature, radio emissions, sound, all correlated in time.
How do they nail down things like distance and size or the magnetic field?
Distance and size can be determined using triangulation if you have multiple camera systems, or via radar. Luminosity is measured using photometry. Velocity and acceleration come from tracking its movement, maybe Doppler shift if it's emitting signals.
And the magnetic field, beyond just detecting a spike.
They use sensitive magnetometers. But the holy grail for a luminous object, like a plasma might be, is to use a spectrograph to look for the Zeeman effect.
Zeeman effect, remind me what that is.
If a light source, like plasma, is sitting in a strong magnetic field, the specific wavelengths of light it emits its spectral lines get split into multiple components. Seeing that splitting is unambiguous proof of a magnetic field within the light source itself.
But you need a really strong field for that, right?
You do. The sources say you need a field of at least 1 Tesla, which is much, much stronger than the nanotesla levels measured in Hessdalen, and the object has to be bright enough to get a good spectrum. It's tough, but definitive if observed.
So how does collecting all this data help test the plasma life idea or other hypotheses?
By looking for correlations. Does the luminosity change when the magnetic field pulses? Does the color shift as it accelerates? Does it emit radio waves only when maneuvering? The sources call this dynamical back engineering.
Back engineering is something you can't actually capture.
Exactly. You study its behavior, its outputs, its dynamics in flight, using all these measurements to try and infer what it is and how it works.
What are the potential outcomes of this kind of study?
2 main possibilities outlined in the sources. 1, they discover some new kind of natural phenomenon, maybe an exotic type of atmospheric electricity, something beyond standard ball lightning. High energy, but natural.
And the other possibilities?
2, the data points towards a technological origin. That could mean advanced propulsion systems we don't understand, or it could potentially point towards something like the non-biological intelligence hypothesized, such as conscious plasma. The data would guide the interpretation.
The sources also briefly touch on other explanations people propose for UAP. Right, just to give the full picture.
They do. They acknowledge mundane explanations like misidentified aircraft or natural phenomena. They also mention psychological factors, misperception, even Jung's idea of collective unconscious projections, and more exotic ideas like Valley's control system hypothesis or even a co-creation process where the observer influences the event.
But the plasma life idea is presented as one specific, scientifically grounded, if speculative hypothesis, arising from the quantum and consciousness discussions.
Precisely. And the scientific methods being developed, like by the Galileo Project, are crucial because they provide the objective data needed to potentially test any of these ideas, including the plasma one.
The sources even mentioned actively probing UAP. With lasers.
Yeah, another potential measurement technique discussed. Shine a powerful laser at an object. Does the beam bend? That could indicate gravitational lensing or magnetic refraction. Do background stars seen through or near the object shift position? That could imply a strong gravity field, maybe from extreme mass or weird physics. It's about actively testing its properties.
It's amazing how the serious study of UAP is pushing science into these really far-out territories and demanding new ways to measure things.
It really is. This whole exploration from quantum weirdness to plasma brains to UAP investigations, it forces us to confront the limits of our current understanding and consider truly profound implications.
Yeah, we've circled back to those fundamental quantum ideas. Bohm's implicate and explicate orders, the hollow movement, the universe guided by a non-local information field via the quantum potential.
And the potential link between consciousness and quantum events like entanglement or collapse, maybe in microtubules.
Then the sources connect all this deep physics and biology back to, well, some of the stranger UAP reports. The anecdotal accounts of telepathy or mind-affecting experiences or even apparent mind-over-matter effects near these phenomena.
Right. They reference controversial research like the P-ERLAB studies that looked into mind-matter interaction. It raises these really deep questions that the sources pose directly.
Like, are external fields from the UAP causing weird mental states? Or could consciousness itself somehow be interacting with or even generating these phenomena? A two-way street.
Are the events sequential phenomenon appears? Then witness feels something. Or are they synchronized, connected non-locally? Is the observer fundamentally part of the event, not separate from it?
It gets into almost philosophical territory. And the sources dive even deeper there with the idea of the quantum vacuum.
Yeah, the idea that the vacuum, the empty space everywhere, isn't empty at all. It might be this vast computational substrate, a cosmic supercomputer, or maybe like a giant universal library.
A library in the vacuum. Holding what?
The speculation presented is that maybe all thoughts, emotions, experiences, maybe the essence of a soul, gets uploaded non-locally into this vacuum network, like a universal cloud storage for consciousness.
And we can download from it too.
Potentially. Accessing information or insights through this field that permeates everything, including the atoms in our own bodies. That empty space inside the atom we started with, maybe it's the interface.
So the universe itself might be engineered. A product of some vast intelligence, not necessarily God in the traditional sense, but something more.
That's one of the most profound speculations offered. The sources even bring in that Nikola Tesla quote about the mind tuning into a great power if focused correctly.
It fits that idea of accessing a larger, non-local reality, like Bohm's ship metaphor.
Exactly. Physical reality, the explicate order, is the ship's engine deterministic, causal. But the non-physical implicate order is the radar, non-local, a causal, guiding the ship via the quantum potential's information.
And maybe advanced ETIs, if they exist, operate more on that radar level, using the physics of non-local information, not just matter and energy.
That's the speculation, a fundamentally different way of interacting with reality.
Which means if UAP are real anomalies, plasma life, advanced tech, whatever, it completely changes everything. Physics, biology, our place in the cosmos.
It would demand a revolution in science, maybe even, as the sources suggest, a new kind of science, not just mapping reality, epistemology, but one where the understanding becomes part of reality, ontology, blending rationality and intuition.
Science has hit weird bumps before, right? The sources mentioned anomalies in astronomy.
Yeah, things like supernova 1987A behaving oddly, the mystery of fast radio bursts and gamma ray bursts, Tabby's star dimming weirdly, stars appearing and disappearing in surveys like FASCO.
In Oumuamua, the interstellar visitor.
Right. Its strange acceleration and shape led some, like Avi Loeb, to seriously consider if it could be artificial. These things push the boundaries and force us to reconsider assumptions.
Even SETI, the search for extraterrestrial intelligence, is changing because of this.
Definitely. The sources point out SETI isn't just listening for radio anymore. They're looking for giant technosignatures like Dyson spheres, using JWST and other telescopes to analyze starlight for anomalies. They're scrutinizing interstellar objects. SETI is now explicitly looking for rigorous scientific proofs of possible extraterrestrial visits inside the solar system.
So it all seems to be converging. UAP studies, plasma life ideas, quantum consciousness, advanced SETI, all asking these huge questions about intelligence, reality, and life beyond Earth.
It highlights how interconnected these frontiers of knowledge might actually be.
So after trekking through all this incredible mind-bending material from the sources quantum foam to plasma brains to cosmic consciousness networks, why should you, listening right now, care?
Well, because this deep dive, based entirely on the fascinating sources provided, it's a testament to the sheer wonder of the unknown and the excitement of the search for answers. It stretches the imagination.
And it encourages us, I think, to keep an open mind when faced with things that don't fit our neat little boxes, while still demanding that we use the best tools of science. Rigorous observation, objective data to figure things out.
Absolutely. And it paints this picture of a potentially deeply interconnected universe, from the tiniest scales within us to maybe sentient clouds of plasma or vast cosmic intelligences, things we can barely conceive of.
We just explored one stack of sources and look at the possibilities they contain, ideas that could literally redefine reality. It just makes you wonder, what else is out there? What other frameworks, what other forms of existence are waiting to be found?
It's a constant process of expanding the map of our knowledge into the vast unknown territory of what actually is.
So here's a final thought to leave you with, building on these ideas. If that quantum vacuum connects everything, if the universe is maybe some kind of information system, could the biggest breakthroughs come not just from bigger telescopes looking out, but from looking within? Could our own quantum nature be a kind of terminal already plugged into that cosmic reality?
Something to definitely ponder. The universe within might be as vast as the one without. Keep exploring, keep questioning.
Thanks for joining us for this deep dive. We'll see you on the next one.